Hello and good day everyone. As the tagline for this 2022 MPI, Innovation and Technology Transformation Post-COVID-19, here we are introducing our project, which is Reduced Graphene Oxide Magnetite Silver, a simultaneous ascorbic acid, uric acid and dopamine sensor. Our project focused on health, medicine, pharmaceutical, food and supplement. Here we are presenting our project members. As a project leader, Dr. Farhanini binti Yusuf, Ms. Otsleen Rashida binti Muhammad Drozli from Sanobi Ultrasound, and lastly M. Zainul Mardhaya binti Mansur. Our collaborators for this project are from UMT, UTHM and Rusense, USA. First of all, what is dopamine? Dopamine is an electroactive neurotransmitter where can be found in blood, urine and extracellular fluid. Abnormal level of dopamine will lead to various neurological disorders such as depression and bipolar disorder. However, there are some issues arise regarding dopamine sensor. High cost and difficulty in selectively dopamine detector have been popularly arised issue nowadays. Hence, to overcome this problem, a fast and an effective response, low cost including high sensitivity and sensitivity dopamine sensor must be innovated. Therefore, to solve this issue, we come with an idea for this project, for a highly sensitive and affordable reduced graphene oxide magnetite silver, dopamine sensor. The materials that been chosen exhibit good characteristic to increase the sensitivity and selectivity of dopamine sensor with an easy and simple method. The novelty and intendedness of our project can be proven as we chose low-cost materials with an easy and simple one-pot method in synthesis of dopamine sensor. The materials with high sensitivity are used in order for low detection of analyte. The process and synthesis of dopamine sensor are less pre-treatment and rapidly process. And importantly, this project able to save cost, time and energy, but we able to inventive a good selectivity and sensitive dopamine sensor. The production process of our project consists of synthesis of reduced graphene oxide magnetite silver, fabrication of electrode and lastly electrochemical method. The performance of our dopamine sensor product being characterized based on Fourier transform infrared. Reduced graphene oxide magnetite silver proven have a sufficient functional group and structural defects, shown it is a good materials choice for modification for electrochemical sensor. Next, XRD characterization was done to prove and strengthen our product's performance. From XRD reading, we can observe from the circled peaks are corresponding to the functional groups based on materials of reduced graphene oxide magnetite silver. Moreover, for the process, the electrochemical method were conducted. Dopamine undergo oxidation process oxidize from dopamine to dopamine-oquinone. Electrocatalytic oxidation of dopamine was done on reduced graphene oxide magnetite silver electrode, and the results exhibits the highest peak value, presenting the most improved electrochemical performance toward electrocatalytic oxidation of dopamine compared to other unmodified electrode sensor. During undergo reaction of dopamine sensor, there are simultaneous detection can be observed due to high concentration of ascorbic acid and uric acid. These compounds causing difficulty to selectively dopamine detection as these two compounds own almost the same oxidation potential as dopamine. Hence, the use of silver nanoparticles material selectivity and antifouling capacity able to promote the separation of oxidative peak of DPV response. Thus, the modified electrode sufficiently increase the sensitivity for the dopamine sensor. Our product effectiveness proven based on the reproducibility and repeatability of the modified electrode, to ensure the best product obtained. The reproducibility step was done based on the measurement of agreement on identical test but different conditions with the same process. The results obtained 10% of RSD% value which meets the target percentage. Hence, we can conclude, our product, the modified electrode has a high stability and accuracy characteristic. Repeatability process also had been done to prove the performance of the modified electrode as a highly sensitive dopamine sensor. The repeatability analysis reveals a 17% RSD percentage and also a fall in the target accuracy of less than 20%. This proven that the composite modified electrode can be used for a few analytical cycles and still gain the desired peak current that is identical. For the commercial potentialities and readiness, based on the graph shown, the performance of our modified electrode resulting the highest compared to the other electrode. The price of the materials are at a low cost where only 4 materials costing consists of magnetite, graphene oxide, reduced graphene oxide, and lastly reduced graphene oxide magnetite silver, which at affordable price for synthesis of the modified electrode of our project. Additionally, the commercial potentialities and readiness of our project's product consist of low and affordable cost for the electrochemical sensor, HPLC and immunoassay. In Benthal we can save cost, the selectivity and sensitivity of the testing instruments are on good condition. The modified electrode, reduced graphene oxide magnetite silver electrode, able to produce at low cost and a sensitive device for low-load analyte as an electrochemical sensor. Our product is the result of development of sensor using biological principle. Last but not least, our project's product also low maintenance. Hence, this shown that our product are useful and easy to handle. As for the aspect environmental friendliness, our product has low solvent usage and low analyte consuming where the waste does not harmful to the environment. Moreover, non-toxic chemicals were certainly safe for the environment are used throughout the production of our project. And lastly, low volume of materials used throughout the whole production process of our project. This product able to contribute to the social and human development as it is an easy handling materials for further analysis of dopamine, low level of detection, and high sensitivity of materials are used. Hence, this project surely able to use as dopamine sensor effectively. Last but not least, green materials are used without consuming toxic materials resulting safely to use for the people. This product surely got many recognitions as the modified electrode is the good product for human development and for future use in sensing dopamine in human body. These are several academic recognitions and awards we got based on our dopamine sensor project. Thank you everyone. We hope our project can get more recognitions and able to give benefits in the future. Thank you for lending your ears and time. Cheers.